Welcome back to the deep dive. We've certainly covered some ground, haven't we? From cybernetics to Shakespeare's sonnets.
And even reliable code and asking better questions. Quite the mix.
Exactly. Well, today we're taking a look at something surprisingly propulsive.
Uh-huh.
Have you ever wondered about the sheer force a penguin generates when it, well, poos?
Can't say I have, but I'm intrigued.
Turns out it's a lot more than you might think. Significantly more, actually, than humans can generate.
Right. And what's fascinating here is that scientists, they actually calculated the pressures involved, specifically for chin strap and Adelie penguins.
Okay. Why?
Well, it was all to understand a very practical biological puzzle. You can sort of think of it like a biological pressure washer, really.
A pressure washer?
Designed for, optimal nest hygiene.
Okay, here's where it gets really interesting for me. How on earth did they figure this out? I mean, penguins are protected, right? You can't just go up and measure directly.
No, definitely not. Direct measurements were basically impossible. You need special permits just to get close. So they used an indirect approach, really quite clever. Researchers observed and estimated a few key things.
Like what?
Well, the maximum distance the fecal material travels before hitting the ground, that turned out to be up to 40 centimeters, surprisingly.
40 centimeters. Okay.
Then they estimated the maximal diameter of the cloacal aperture at the moment of, well, firing.
The cloacal aperture, that's the exit point, right? For our listeners, maybe not up on penguin anatomy.
Precisely. The common opening, they figured that was about 8 millimeters across.
Okay. 8 mil.
And they also estimated the height of the cloaca above the ground, roughly 20 centimeters.
Right. Simple observations.
Exactly. And from those, they could calculate the initial velocity of the droppings.
Which was?
About 2.0 meters per second.
Wow, that's actually pretty fast for poop. So what did these calculations finally tell them about the actual pressures? Give us the numbers. How does it compare to us?
The numbers are quite something. Fully grown penguins generate pressures between 10 kPa. That's about 77 millimeters of mercury when expelling watery stuff. But it goes up to a staggering 60 kPa.
60.
Yeah, 60 kPa or 450 millimeters of mercury for the more viscous material. They said it was kind of like olive oil consistency.
450 millimeters G. How does that stack up against humans?
Well, for comparison, normal rectal pressures in humans are usually around, say, 20 to 55 millimilli Hg.
Right.
Even if someone is, straining, pressures might get well above 100 millimilli Hg.
Okay, so penguins are way beyond that.
Considerably greater force, yeah. Regularly, possibly reaching like half an atmosphere of pressure. It's really a remarkable biological feat.
That sounds like serious power. So what's the point? Why so much force for, just going to the bathroom?
Well, it boils down to evolution being practical. If you connect it to the bigger picture, it seems birds propel their feces as far away as possible.
Makes sense.
And with minimum effort, importantly. This is crucial to avoid soiling their feathers, especially because brooding penguins don't leave their nests.
Ah, okay, so they're stuck there.
Right, they just back up to the edge and let loose, fire away.
Got it. Efficient waste disposal.
Exactly. And interestingly, even with these high pressures, the forces involved don't create an energetically wasteful, turbulent flow. Meaning it's a very efficient process. Smooth flow, despite the power.
So powerful and precise. And I think I heard there's a colorful little detail, too.
Yes. Just as a fun aside, the color of the olive streak actually depends on their diet.
Oh, yeah.
Fish results in a whitish streak, while a diet heavy in krill makes it pinkish.
Nature's a little color chart. Okay, let's unpack this for our key takeaways.
Sure. So first takeaway, penguins produce surprisingly high pressures for defecation. We're talking 10 to 60 kPa or 77 to 450 milli-Hg. That far exceeds what humans can do.
Right. Extreme biology.
Second, this powerful, efficient propulsion isn't just weird, it's a crucial adaptation. It keeps nests clean and their feathers pristine while brooding. It's nature's clever solution.
Survival engineering.
Pretty much. And finally, complex biological forces like this one can sometimes be calculated indirectly just by observing simple things in the environment.
Even for something like penguin poop.
Exactly. It really shows the ingenuity of the scientific method. You don't always need direct measurement if you're clever about observation.
That really raises an interesting question, doesn't it? What other everyday, seemingly simple animal behaviors might involve incredibly complex physics? Surprising forces that we just never stop to consider.
Makes you think.
Maybe next time you see a bird, you'll think about the impressive force of nature it truly is. Or maybe just don't stand too close to the pool position.